We're going to talk about hormones and the endocrine system. I'm going to really try to make this as simple as possible. Sometimes on my YouTube channel, I'll get feedback telling me that I'm oversimplifying a body system, right? I shouldn't make it too simple because the body is very complex and only certain people can understand it. So only if you graduate from a certain university and you have a certification can you talk about the body. Well, in fact, I disagree. I think you can understand the body, but the endocrine system sometimes sounds very mysterious, but really it's a communication system. You have the nervous system, you have the endocrine system. They both allow communications to occur in the body. So let's just take a look at the endocrine system. So you have the gland that makes hormones. Okay, hormones are communication particles, and they deliver messages through the blood. These hormones are then sent to certain tissues, okay, that have receptors. So very specific hormones go to very specific receptors to do very specific functions, okay? That's the simplicity of it. We have a hormone communication that's sent, it gets received, and it does its certain function, okay? There's 3 types of receptors. You have receptors on the surface of the cells, okay, membranes, receptors. You have receptors inside the cell, certain places. And then you have receptors that also go into the center nucleus, okay, the DNA. Like the thyroid hormones, for example, can go to really penetrate the cell, go right to the DNA. So they can affect genetics. So what happens then, once this hormone is connected, there's a little signal that gets sent back to the gland, letting the gland know that that message has been received and acknowledged. So in the endocrine system, we call that feedback loops. So there are negative feedback loops and there are positive feedback loops. I'm just going to talk about the negative ones, which basically just tell the gland to turn off, okay, to lower that hormone. So that's really what the negative feedback is. It's just a signal back to turn off the gland because the function has been complied with, okay? Now, in this dictionary, I'm just going to show you the definition of the word acknowledgement. Thing given or done in recognition of the arrival or receipt of something, okay? So, if you order something from my site, I send you an email back letting you know that it was shipped. And then on my side, I get feedback from the fulfillment center that that package was delivered, okay? So that's my acknowledgement. And when you're talking to someone, they're going to acknowledge what you said, so that way you can feel that they heard you, okay? But if they don't acknowledge you, you might have the tendency to keep talking, okay? To try to get your point across. That's why it's very, very dangerous to ignore your spouse. But the point is that the acknowledgement tends to complete that communication, okay? Now, why is that important? Because when we deal with hormones, we're dealing with also something called hormone resistance, okay? I don't know if you ever heard of insulin resistance. Well, there's also leptin resistance, cortisol resistance, estrogen resistance, testosterone resistance, and even thyroid resistance. This receptor is the superior thing in this entire communication platform. So we have the receptor over here that's listening, and then the hormone in the gland is talking, and they connect, and we have this whole normal function. Now, this is a very common problem, especially when we get into insulin resistance and even cortisol resistance, which I'm going to do a separate video on this. Now, what this receptor is doing, it's actually protecting the body against excessive communication of that hormone. Okay, that's what this resistance is. So we have something that's triggering the gland to make too much of this hormone, and then the cell's going to protect you because too much of a certain hormone can be bad, especially when you get into cortisol and you get into insulin. It can be very destructive on the body. So when you have insulin resistance, you no longer have this feedback loop, this negative feedback loop going back to the gland to turn it off, okay? So if we don't have the feedback, then the gland never gets that communication that this has been connected to, so it starts to increase more and more communication to connect. Now, you've seen this in human relationships, right? Where someone just keeps talking and talking and talking and talking. Well, the more you ignore that person, the more they're going to keep talking. So you might as well just listen to them, acknowledge them, so they will stop talking, okay? The same thing happens to the body. If you block that listening mechanism, that receptor, then the gland will keep pumping out more and more hormone. Now, in the case of insulin resistance, you have from 5 to 9x the amount of that insulin that's being pumped out of the pancreas. So you have so much more insulin than you really need. And what's happening is that hormone's trying to connect, but it won't let it. But really what's happening is that the reason why that gland is pumping it out is because something is triggering the gland to produce that hormone in the first place. So we have this simple communication system that's now very complex, but if you understand the basics, you can see it very simply of what's happening. For example, insulin resistance, and we will look it up online, Wikipedia, which we know everything on Wikipedia is truthful, so we can read this right here. Insulin resistance, the very beginning part, it says, avoiding carbohydrates and sugars, a no carbohydrate diet or fasting can reverse insulin resistance. And they give 2 references. Okay, you can look this up yourself. Okay, so that's very interesting, right? So one way to fix this resistance problem is to stop stimulating the gland with that trigger that's causing the problem in the first place. And the reason I'm bringing this up is many times when you go to the doctor, that individual will measure your hormones and say you have too much of a hormone or you have a hormone deficiency. Call it a hyper or hypo, okay? And then they'll either give you a hormone or they'll give you medication that blocks a hormone instead of really understanding the big picture, okay? Especially when we get into even like hyperglycemia, high blood sugar, or hypoglycemia. So what I want you to do is understand the simplicity of what's happening with this communication system and realize that there's something triggering the gland. In the case of cortisol, which I'm going to do a separate video on, that's stress. Okay, so that'll actually keep the body pumping out excessive amounts of cortisol. And you'll find out when I do the video, you'll have high amounts of a certain hormone. It's called Cushing syndrome. Yet you have all these symptoms of low cortisol. So it's extremely confusing, but if you understand this, you can understand it very simply. Now, in the case of insulin resistance, you have symptoms that are too much insulin and symptoms that are actually insulin deficiency. So now you'll know why, because it's the receptor. So the receptor is definitely the superior factor in this entire communication network. And one last thing, since we're on the topic of insulin resistance, inflammation in general can cause insulin resistance, and insulin resistance can cause inflammation. Of course, carbs will do it. Frequent eating will do it. And also, if you look up insulin resistance, you'll see obesity is one of the causes of insulin resistance, which I disagree, because obesity is really a symptom of other things, definitely high levels of insulin and insulin resistance. So this is really a symptom. I mean, it is true that visceral fat will actually make insulin resistance worse. That's true, okay? But insulin resistance causes elevated insulin, which then causes visceral fat, so it goes around and around in a circle. Or sometimes you'll see this, a high-fat diet causes insulin resistance and it's going to eventually cause diabetes, which is totally a lie, because the studies that they do on high-fat, it's on mice, and if you look at the actual diet, it's not really just a high-fat diet, it's a high-fat and high-sugar diet, okay? And that actually compounds it. That's actually worse than taking a diet that's just high carbs. If you combine the two, that's even worse. Okay, guys, so thanks for watching, and I hope that now that you understand some of the basics, it makes more sense. So if you want more knowledge on how to create a healthy body, subscribe now and get daily notifications. Daily notifications, that sounds weird. Well, I'll just remind you on a daily basis. How about that?